certainly, commercial ready, but it's, a Rev Alpha, and there's both good and bad for them. So we'll kind of discuss the good, the bad, and maybe some of the improvement items that we can look at here. Also, there's a couple jobs in the backlog. So going through a job description that is actually in our backlog and kind of just, looking at it how I would look at it and how, we should be looking at them for processing jobs, and then just questions and answers. So outside of the scope is just platforming and workflow process. So these are certainly important discussions for us to have. It's just, I'm trying to really level set everyone at a level where they understand how the unit works, and before we kind of get into that other stuff, just so everyone's on the same playing field when it comes to those topics. And there's some of the electricians had to go out for service calls, so we're kind of light on electricians. So there's a pretty good chance we'll have extra time towards the end for additional questions and answers that maybe are to do with the platforming and workflow process and stuff like that.
I can start a recording too.
Oh, okay, that'd be awesome.
That way you can rewatch it.
Perfect. And then the handouts I have is just these are both things I've sent, and as well as there's other things I sent in that email, but just the full system wiring diagram. So this is the more of an overview one-line type wiring diagram. I call it a one-line, even though you can see all three phases, just because there's some things that are simplified in it, but it basically shows the overall system architecture of the control system, as well as the fundamentals of the high amperage ATS document. Which is a really just an overall reference of how the system works, and that I wouldn't say that document is fully inclusive of everything you'll need to know, because there are a lot of elements like, how this sits within a platform that are pretty important, but this is just to cover, from beginning to end. If you read it through, you should have some understanding of how to build one of these things and how to edit them and that kind of thing. So that's the goal. And I do foresee us doing a couple more shorter workshops, one more to do with, more directly with Jake's team and their side of like, okay, we know how these things work. We know what the improvements items are they worth it to go after, and that kind of thing, as well as I have a bunch of these units waiting for testing out on the floor. So I think it'd be kind of fun to take a group out there and we go through the testing, the low voltage testing, and see how they actually work. They're pretty cool in person and very loud if you haven't heard a WL breaker go off. So, all right, project purpose. So I'm sure many people know this, but we have a current generation of ATS units. We use the ABB True One series of automatic transfer switch. It's an all-in-one transfer switch, and it's offered from all the way from 30 amps to 1200 amps. We typically don't go as low as 30 amps. I think 100 is the lowest we go, and that's for the MA. That's for the UL versions of these ATS units. And our docking station line generally sees units anywhere from 100 amps all the way up to 5,000 amps. And there's a big gap and a big opportunity within that 1200 amp to 5,000 amp unit. So it's kind of like we can see this high amperage ATS project as something that fills in the gap that the ABB True One series does not offer, because, as I show in my caption here, the ABB True Ones are a really, really cool piece of technology, and they include a lot of things that inspires the design for this unit, but they're just very, very low ampacity. They can't handle most of the stuff we put in a pad mount. So yeah, and it's kind of the way to fill the gap, as well as we'll talk a little later that, especially when we get into the talk about one lines, the True Ones are not service entrance rated, and they're not an overcurrent protection device, which, our ATS design brings all of that in. We have ground fault, we're GFI, and all of those things. So even though it's a really, interesting and cool unit, it doesn't fulfill all of our needs and doesn't fulfill the ampacity requirement there.
Do we know, do we have a roadmap? Because we've always heard that they're going to be coming out with bigger and bigger True One units.
Yeah, and they seem, so I've talked to them about it, and especially within the context of some of their technologies. We really looked at ABB in terms of their technologies and stuff, and they just didn't seem super interested in going that much further up the chain. I mean, I've heard rumors of a 2000 amp version, but when we get to, when you look at the quoting, the mainstays for this product are 4000 amp and 3000 amp, and they haven't seemed interested. Of course, they probably won't tell me everything, but it hasn't seemed like there's too many rumors in that range, at least.
Insider knowledge there is that nobody was working on that 2 years ago.
Yeah, that makes sense. I mean, you know, when you start stepping up into that level of ampacity, you have a lot of internal stuff you got to work on to make these a lot bigger, and you know, they would turn into 1,000-pound units you have to crane in. So yeah, it kind of makes sense that that wouldn't be there. As well as that, you know, the project purpose here can go beyond this, where we're effectively just putting technology on units to control breakers with some logic. And so any type of, you know, switchboard and the like can use this logic to, you know, switch between different power sources. It's kind of our first foray into using some of the technologies available in the WL series and the WA series in the future. And we'll get a little bit into the different types of breakers and what's possible. So general principles, overview of how this unit works and kind of what we're working with here. So at its core, the high amperage ATS uses two breakers to act as a switch between two sources and the load. And so we can see up here in this diagram right here, we have a source 1, source 2, and the load. And so in this case, we can open one of the breakers and close the other one to have the closed breaker source feed the load. We can also have both breakers open, which is nice if you have, you know, no loads that are, or no sources that are available. But you cannot have both breakers closed, obviously, and that's pretty common within our one line is the concept of interlocking. So this is the basis of the high amperage ATS system, this little one line. And there's a couple options for sources. The most common and the one you'll see 99% of the time is the utility to generator. That's what the TriStar facility is running off right now, and high amperage ATS that transfers from your utility power, which should be always present, to backup generator power. And there are different things in the ATC controller we'll go into a little later that allow you to switch to a generator at different times. But typically, this is for emergency power generation. So the utility goes out and you need your generator to come up. And you'd see that in industrial facilities, hospitals, data centers, stuff like that. As well as that, you can have two generators, and this is a lot of times seen at remote sites. So you'll have a mining site that doesn't have, it's too expensive to bring utility power out there, and you don't want to run your generator 24/7 for too long. So what they'll do is they'll do 2 weeks of running one generator, and then they'll have the automatic transfer switch over to the other generator for 2 weeks, and then they'll do maintenance throughout the week on the one generator, constantly keeping them online. And there's capability within the controller that we can program in that does a timer like that. It directly supports this transfer of generators directly. So there are some considerations later on that we'll go into with the different sources, and this is something that needs to be in the quote that we get from CX, because it's really important to know what exactly they're trying to do. This should also be covered in the riser diagram, which is also a required concept to get from CX. So, you know, it definitely the context of these units matters and the availability of power. As well as that, it does support utility connections. And these are generally, I would call them the easiest because you don't have any auto start capability. You don't have any controls related to the generators. It's basically just two loads that are or two sources that are either there or they're not. So very easy for the controller to manage.
So Jack, are you taking questions now, later, never?
So I want to do a lot of questions at the end, but throughout it, absolutely. I mean, I want it to be a back and forth and discussions on each thing. So yeah, I'll take questions
both.
now.
Now,
Yep.
okay.
Yeah.
So tell me why I cannot have a renewable source from a solar panels or wind turbines or hydroelectric or whatnot. Why are we restricted to those three?
So you absolutely can have different, I mean, the unit that we have out there does have different power sources. It's just, it's fairly atypical to see coming into an ATS, an automatic transfer switch, it would be a rare enough case where I didn't mention it to just see renewables coming into one side and having a hard transfer over to them. A lot of the renewables like to sit in line on the utility waveform. So for instance, if we have a utility connection or a generator connection, the utilities would land on the load side, like we do out on the Acorn Trail microgrid, because those like to snap onto the grid and kind of help feed power with the generator or the utility. Could you just have a renewable source coming in one side? It's possible, but renewables like to have strange waveforms when they aren't being led by a generator utility that might cause some strange behavior with the controller. It's possible. Because they're not directly creating a true sine waveform. They're doing like a PWM version where they're flipping on and off switches. So it's possible, but it's not fleshed out by Siemens, who's the manufacturer of the controller.
And so if we had a BESS that was storing energy from a solar panels or something, that would still be a challenge.
Yeah, that would be, I would say that would be something that it either it works or it doesn't. There's not too much we could do to adapt it to this system. But typically if you have a BESS and you have like an automatic transfer switch, you would typically see it on the load side, but it is an interesting consideration there. And it would have its own breaker and that kind of thing, or all of them coming into a switchboard of some sort. Yeah, but that is not something that's
Yeah, okay,
currently
that I think makes more sense to me, that if by the time you start adding renewables, maybe we're talking about a switchboard, not an
Yeah.
ATS.
And
Okay.
one thing to really, that's a good point, is one thing to note here is that the switchboard, this load connection goes to your switchboard. So the next point this load connection goes to is the switchboard with all of the different loads, and that's where you see a lot of
So
your,
from a solution standpoint, when a customer brings that up, maybe we can reframe the conversation in terms of a switchboard.
absolutely,
Okay.
yeah. And there's likely a lot of different pieces, this is one piece of the puzzle of some kind of riser diagram, and the switchboard's another piece that we also do. So there's a lot of pieces we can take there. And then below here, this is just the equivalent one line. I mean, we can kind of ignore what the connection point is here, but this is the equivalent one line to what this is basically doing here. And this is another equivalent one line because the breakers do implicitly make it service disconnectable, which is convenient. And like I said, just a little, another point here is that this one line is not like the only one line you can do. This is just a piece that has to be within the one line. So you can have dual purpose, multiple loads, temporary generator cam locks, load bank connections, all of that. It's just this portion of it being what it is pretty important because you need that kind of architecture to actually make a switch between the different sources.
That's the same thing as a switch, basically.
Yeah, that is a switch.
Yeah.
Yep. So, and we'll go a little more into one lines and talk about, what to look out for. But if you see this arrangement, you're pretty safe typically. All right. So in this case, we have our one line that works, which is, then they're just breakers. They're just sitting there. So we need a way to be able to control the breakers, which we currently can't do within our platform for standard pad mounts. And in this case, we do that through breaker accessories. There's 4 main breaker accessories to know for controlling the breakers themselves. And that is the spring charging motor, the shunt trip, the closing coil, and the bell alarm. And so the spring charging motor is a little motor that sits, you can see it actually up in the top right here. It sits within the breaker. You can install it on the breaker, and it charges up the coil of the breaker. And what charging up the coil of the breaker does is enables the actual mechanical mechanism that opens and closes the breaker to work. So it's like the power source for the breaker effectively. It's what makes it able to open and close. So the spring charging motor makes it so you don't have to sit there and pump up the breaker every time you want to actuate it, which is very important for remotely switching the breaker. The shunt trip is another accessory within the breaker that opens the breaker instantly when you energize it with the rated voltage for that shunt trip. We do have shunt trips that go in a lot of our units. So that's not too uncommon of one, but typically the way we're using shunt trips is you have some kind of control signal that's coming into it that's telling it to open under some kind of fault condition. We're not doing it so much to, actually change sources. As well as that, there's the closed coil, which is like the shunt trip, but the opposite. It closes the breaker when energized. One thing to note about these is that they don't use a ton of power, but when they are using the power, it's a decent amount. So it's only like 50 milliseconds of runtime, but it can get up to, I recorded up to 150 watts per little accessory, which is quite substantial, especially if you're using power through a power supply, which a lot of our power supplies are only do 240 watts total or 480. So definitely something to consider there. As well as that, the bell alarm. So the bell alarm is just a contact that opens or closes based on if the breaker is in a tripped state. And all of this is doing in our case is saying, it's telling the controller basically, hey, if the breaker tripped, it's not opened by the control system. If it tripped because of overcurrent, do not try to open or close the breaker again. Leave it in its state, because in a trip condition, we don't want the controller to keep trying to close it into fault conditions. That's a really important point.
So is there a question here for our salespeople to answer with respect to what I'm going to call this DDAC function of your activation that's consuming 100, 150 watts or whatever? Doesn't that tie back to the sources, and some questions should be answered there, correct?
In some regard, it's more a consideration for how we spec our control system parts, because in the grand scheme of our pad mounts, this 150 watts is just a minuscule amount of power, but for control electronics, it's quite a lot.
Oh, okay.
So
So I'm
it's-
missing that part.
Yeah.
So it's obviously out of ignorance. So it's not an issue with the customer. It's an issue with
Yeah.
our vendors.
Yeah, exactly. And when we talk about, just for context of 150 watts, I mean, our units commonly see megawatts, so millions of watts, through
I see.
a couple.
Okay,
Yep.
that makes sense.
The closed coil too, that's something that we add to it for this case to work with the spring charging motor. That's different than the standard, the trip coil that would be in it that we'd use with the actual pump panel. You add that to be able to do it remotely, basically.
So the closed coil, it's just the opposite of this shunt trip. All it is you have some kind of voltage, which you can decide based on what you need, whether it's 120, 480, or 24. And you just apply that voltage to the closing coil and it automatically closes the breaker up. It does work in tandem with the spring charging motor, but not directly. They just are, they're relatively necessary together, because if you want to automatic transfer switch and your coil's not closed, your controller is going to try to close the stuff, but it's not going to work because you have no energy stored within that breaker to actually activate it.
Isn't the spring coil what would be used with just a manual handle normally? You basically pump that up and that's what you are able to close that breaker with.
See, I know what you're talking. There's some kind of spring coil call out in some of our quotes. Siemens uses different terminology for so many of their different accessories. And I don't exactly know what the spring coil is, what they're referring to, because you can see the spring charging motor be called the motor charger, the motor operator, all of these things. Siemens is not very good with their, nomenclature. So I don't know exactly what they're referring to when they say that kind of coil.
But that's definitely something that we got to add to it for the being able to close it remotely.
Correct. Yep. So you have shunt trip for open, closed coil for close, and then spring charger to make sure the breaker's in a state where it can accept those commands, basically. And then your bell alarm's just a indication back to the control. So
I look at the characteristics table for the closed coil and the shunt trip. Are those numbers, is that copy pasted from a vendor brochure?
yes, so this is all this, and I have kind of a reference. This is all of the references you'll see that are unnamed are from the Siemens WL breaker manual that we use.
And when you made the choice, it was based on those characteristics. I guess I'm getting at, how do we help our procurement folks stay within the guardrails and not procure parts from other vendors that may not satisfy that power consumption condition? Because I see 120 watts for 50 milliseconds
Yep.
in both cases.
So that's a good point. And I think, so with the Siemens breakers, the WL or WA, these are the only acceptable items that we can use because we are using these are accessories for the Siemens breakers and we're using it. So there's two ways we can do it, and I have it below here. We can order them a la carte, so we can order all these parts and then put them in the breaker, which is annoying. Like we spent like 3 days putting all of the components in for this job, or you can have them pre-installed by Siemens. So Siemens will actually take a spec that you need for their breaker and include all of these options in it and just give it to us like that.
So then we specify for a procurement team, we specify pre-installed as recommended, a la carte, if truly necessary.
Yes.
And if another vendor comes in, do nothing, talk to us first.
Exactly. And
Okay.
and the pre-installed lives within the part number we order from Siemens, so we can directly say, this is in the BOM, so we don't even have to tell them to have it pre-installed. Siemens will just do it for us.
No, but in some way, we gotta give them an option for a la carte, so that,
Yeah.
so for whatever reason, it may make sense at some point. Maybe there's a force majeure at Siemens or God knows what.
Mhm.
They still need to know that the a la carte is an option, but that nothing else is.
Yes.
So I know this is order execution, but at some point it overlaps with procurement, correct?
Yep, and there's enough, I mean, it is order execution, but there's enough here, like there's different voltages for these things, which we'll go over. Like there is some, depending on what kind of control system you're running, there could be changes that engineering will do. So it just, yeah, they shouldn't change within like a product ID, for instance, for the same build, but across builds, they definitely could, right?
So let me ask a question a different way. We have systems in place where we can specify that, and if people are following those specifications, either we're fine or they come with a question to the
Yes.
engineer.
Yes, and we'll just send the
Okay.
part number right on over to them because these kind of things are, like you said, I mean, they have some characteristics that are very particular. And so it's not something we can just give a spec sheet for and say, try to order the right thing, right?
Mhm.
Yeah, absolutely. And then sequence of events. So with the components installed in the breaker, they can complete a full open cycle remotely. So this kind of shows, I mean, it's just basically review, but breakers in an open state, let's say, you know, the motor charger, so let's say it just got open for some reason, and we want to close it and open it again. So we charge, the motor charger gets energized and it charges up that coil. The closing coil then gets energized, closes the breaker, and then we energize the shunt trip right away, open it back up. So that shows full controllability over the breaker state through these couple components here. Okay, so that's all fine and good. We have some kind of control for the breakers, but how do we actually tell the breakers at the right time to open and close? And that's through this unit right here, the ATC 6300. So this is a Siemens product that's made to be used with a ton of breakers, but particularly with some of the breakers we tend to like to use, and we can pass it around. That's for one of the later jobs. But so this device effectively takes in signals that we choose it to take in, whether it's voltage, frequency, those kind of things, and it makes decisions to activate different accessories on the breaker. So whether it's a shunt trip, the closing coil, those kind of things. As well as that, it can activate enunciators for errors. And when it comes to the programming of this thing, we have hundreds of parameters we can set for different conditions for the customer. So it's very flexible. It's not quite what I would call a full PLC where you have full ladder logic control over the thing, but it's somewhere in between programming and, you know, changing settings. It's somewhere in between there, and it's a nice medium for, you know, an engineer who knows how this thing works but maybe isn't an expert on control systems. Anyone can go in with some knowledge and learn how to program it.
Who is programming it? Or is it
Me
the
right
customer? You
Um,
are,
so-
we're setting it up before we send it out.
So we're setting it up per the nominal voltage, nominal frequency, the standards that we know are going to be involved with the job. Specialty functionality, and this is maybe more of a question. I mean, I've had this discussion with Christian a little bit, but you know, a couple months ago, and it's like, how deep do we want to go in programming this for the customer? If we commission it, we probably go all the way through, but for the most part, it's just making it a automatic transfer switch that works for the conditions set in the quote. And then we deliver the manual for the ATC controller along with it. And if they want to do something extra, they're more than happy to. We do have to do some programming initially though, because this controller, I mean, if you look on the box, it has a bunch of German words on it. It's all 400 volt, 50 hertz. So we have to configure it into that 60 hertz, 480, or what the American standards for the companies will be shipping it to. But yeah, then we'll go into a little bit of like how we program it and what the workflow is for that, because there's the way to go through the controller and program each little item hand by hand, or you can actually plug something in and do a power config and just upload it all. But it's a good question in that there is another deliverable beyond electrical and mechanical, and that is the parameters for the controller. So that is deliverable from the engineering department for these things.
How many different configurations do you have pre-established?
So we have, effectively, we have one that works for 480-277, a utility to generator connection. Now, when it comes to being across voltages, it's as easy as, and all of the relevant parameters are within that document. There's a laundry list of them, but it's as easy as just editing one parameter. It's really simple. But when you get into more of the niche stuff, that's where you start getting iterations, and that's a case by case basis. The general builds, you could establish those parameters. All it is changing the nominal voltage from 480 to 600 or 208, right?
That's all managed by that device for not going into the source code to stuff.
Correct. So those high level parameters are just their numbers in there. Yep. You still, you have to look at your percentages for tripping and that kind of thing, but I wouldn't say it's any more advanced than configuring a WO breaker or, whatever. There is another voltage monitor in there. It's kind of like a PRM, but more advanced. It can do full voltage monitoring, and that's for the control logic. That also gets configured with matching parameters to this thing. But that is also very easy. It's just numbers in that thing. So we can kind of put together all of the actual parameters are in that document that are relevant. So maybe that entire list somehow gets delivered with possible changes. But within the power config software, I think it's generally like the electrical engineer or electrician on the job figures the parameters out we need, and then that's just done in the power config software, and then it's up 5 minutes or whatever it takes to upload it onto the thing.
And do we have, without this physical item in front of us, are we able to set up those configs?
We can set it up in the power config software. You need to connect to this little IR. Josh just ordered one. You have to connect into it and upload it quickly.
Okay.
And then it'd probably be smart to verify that the parameters uploaded.
Right.
A couple times.
I'm thinking more during the design stage. We don't have to have that individual screen in order to have the power config.
Yeah.
Upload.
And I haven't messed with the power config too much because I like taking 20 minutes to go through the parameters myself. We didn't have a cable. But it's kind of like, I don't know. I think I can't see a world where you don't have something where you can save like 480-277 volt config 60 hertz, right? These are used by a decent amount of OEMs, and so it's like it's supported through OEMs. And we'll go in much more detail a little later on. I'm going very slow. So this is the overview wiring schematic for the unit, which is I passed this out earlier, and we're gonna go section by section on this, but this is just the overview for the initial units. And there's some, like I said at the beginning, there's some good and there's some bad in the initial design. And there's maybe some changes that might be prudent to add to this unit, especially as we move forward with more volume, and we'll go through those too. All right, so electrical system, the ATC 6300 to breaker connections. So these are the connections we were talking about before, but this is a little more detailed look into them. So this unit up here represents the ATC 6300 and all of its connections on the back. These are the two breakers that you will have within your job with all of the different accessories like the shunt trip, the closing coil, and all of the different auxiliary alarms. And so I made it a little bigger so it's easier to see because it's impossible to see down here. But effectively, the electrical connections and the way it works is you have some kind of 24 DC volt or 24 volt DC source. In our case, it's a power supply. We'll show the power supply in the power section, but we have some kind of 24 volt DC source, and that is going through a relay. In this case, the relay lives on the controller. So the controller controls this switch on or off based on system state. So these are the parameters we talked about. There's all the parameters and ways to make the controller work. This switch is activated based on system conditions, voltage, that kind of thing. So let's say we have under voltage, let's say the voltage drops off from the utility line. Then likely this switch would close and activate the shunt trip. So when you have 24 volts across the shunt trip, it opens the breaker. So there's two of these logic forms per ATS because we have one on each breaker. So all it's doing to activate the shunt trip is closing a little relay on the controller itself. So that lives, right here on it gets connected right in there. And so, yeah, and the closing coil is a little more involved. I decided to add what's called an auxiliary interlock to the logic here because we have a mechanical interlock, but I also wanted the software or the electrical system to have an implicit interlock in it. And what this does is we have 24 volt DC that also goes through a relay on the controller. So it can decide to activate it or not activate it. But in this case, it has to go through a contact on the opposite breaker first. And what this contact does is it says, breaker 1, are you closed or open? And if the breaker 1 is closed, this auxiliary interlock is going to be open. So it will not let the controller close breaker 2 because it knows that, we can't have both breakers closed at the same time. It's a really bad deal. So this is physically not letting the signal get to the other breaker closing coil until it goes through an interlock that says, I'm open, you're free to go. So it's optional because we already have a mechanical means of doing that, but I just added it in for extra safety and redundancy. So yeah, so that's that connection. And then these are just the auxiliary alarms, which are,
Well, you said safety.
yes.
Do you mean resilience or you mean safety?
So if both breakers close at once, that could let out of phase generator and utility on the same line, which can cause massive waveform distortion, which can cause damage to our equipment, damage downstream, or malfunction of what could be look at the punch. If we fed the punch out on the floor dirty power, it could maybe malfunction in a way that could be dangerous to people. So that's why it's a safety mechanism is, even though it's not super obvious, clean power is safe power, right? That's important. And then of course we have the auxiliary status and alarm auxiliary. Alarm auxiliary is just the trip indication I talked about. This is the way it's wired in. So effectively, you have some kind of relay on your breaker. So these are located on the top of the breaker in those big I/O modules they have, kind of up by where we do ERMS, the COM35 module. And what we're doing is we're bringing a common port from a PLC relay output. So some kind of power from the controller, we'll call it. In this case, I chose 3.3 volt DC. And we're going through this switch. And if the switch is closed, that means it senses it at this digital input. And so we know there's a trip. So that's how it detects the trip condition of each breaker through the bell alarm. There's also a status indication, which just feeds back the status of the breaker. So the difference between the bell alarm and the status is bell alarm only is a trip indication signal, whereas any open or close on the breaker is through the status. So the status basically feeds back, just making sure the ATC knows the system state. That's it.
So with this, are we able to outfit the breaker with other alarm?
So
Functionality.
that's a great question. So we have, now you're gonna say, so we have full control over the digital inputs and full control over whatever kind of alarms we want to go off the WL breaker. So we can program our own alarms into the ETU and into the breaker and do any alarm indication. It could be, phase rotate. We could get rid of the phase rotation monitors and do phase rotation in the breaker, do alarms for that. I mean, yeah, there's a lot of capability there. So those are the main connections here. And note, there's a lot of wiring here. The reason it looks so much more involved than this is there's two sets of this, as well as there's terminal blocks. So we're not running all of these individually. We're just commenting up all of the 24 plus and minus and pulling it all from one big block. So that's why it looks complicated. And the blue represents plus 24 volt DC. The blue white stripe or the light blue is minus. And this is just a section of this main wiring diagram as well, just for reference. All right, so voltage taps. So this is another section, just breaking down the electrical system slowly, trying to make it simple. This side over here represents the bus bar and the breakers themselves. So this is the breaker switch over here, the actual disconnecting means on the bus bar. And then this is the bus bar themselves. So we pull taps through little 12 gauge wires off of each side of the bus bar, the utility and the generator, or it could be another utility, whatever we're running. On this side, we have a fusible disconnect, which is very important. We'll go into service implications on another slide, but we have a fusible disconnect. We can connect and disconnect power from the control system with overcurrent protection. And then we have another set of, this is not a disconnect, but a fuse holder. So it's just protecting the controller from a fault condition, because remember, these are being tapped from the bus bar, and this is actually not even being tapped. There's no overcurrent protection on the utility side typically, because it's coming straight from the utility transformer. So we need overcurrent protection there because you have, I don't want to say infinite fault current potential, but a lot of fault current potential coming straight from that utility transformer. It's whatever it can handle, which is a lot for those things. So overcurrent protection integral on coming off of the taps. These feed directly into the controller on the line, the top side line taps here. And what's nice is we can pre-wire these and just stick them in there. And so this is what helps the controller make decisions about the state of the two lines. So if it sees, it's going to measure voltage here, it's going to measure frequency, phase rotation, phase imbalance, all of the parameters you could ever want. And those can all be enabled or disabled in the controller itself. You want to make sure your combo's right, so you're coordinated right. But yeah, this is the main place that the controller measures the different sources from. As well as that, we pull taps. We pull 277 volt taps from line 1 to neutral here to power the control system. And so this is, we'll go into this next, the voltage monitoring relay setup over here, but this is probably the most complicated part of the system and the most involved for us. But we have two lines of power that switch on and off, and our controller has to work in the worst case scenarios because that's what it's made for. It's to switch over, and when you have power quality issues, all of these different things. So when utility power shuts off and your generator's not on yet, this device here, which is a bunch of devices, handles keeping power to the controller if it's available. And it's mostly relay logic that is done in. And another thing to reference is, we'll go back to it, but this is one of the main things that will have to be switched. The actual components will have to be switched between the voltages, because this is 277 voltage dependent. And so you need different contactor coil voltages and the like, but we'll go through that a little bit. This is the power distribution system for, this is effectively what I just described. It switches between the two sources. It monitors the 3-phase, and it switches between line 1 and line one and line two to the output to the control power. And so there's so many mixed up, it's relay logic. So there's a lot of wires going around to different places and circling back on itself. So I can't really describe how it works very easily here, but within the packet I sent, there's a truth table that goes through the conditions for the different lines and how the output will work, the logic, because it's just a little too complicated to break down without the truth table. But basically, the general concept is it favors line one power pass through because that's our utility line. But if line one has some kind of problems, it will switch over to line two immediately and lock it in place. If both lines are active, line two or line one will pass through. So it's basically just it's a mini ATS within the ATS, the way I look at it.
Is that where you have the scenario 1 through 6?
Yes,
Okay.
those are that's the truth table scenarios that will go through and this is all stuff that is done internally. All of these components, I mean, these individual contactors we're sourcing and all of that, this is our own logic, we can call it. I mean, this is also the subject of what I sent you for.
So does is line one supplied by source one?
Correct, yes.
Okay, so, and the same for line two?
Correct.
Source two. So when you have generator, it sounds like the way you set up the sources here, it always favors line one regardless of whether it's utility or a generator.
Yes, it will. Well, yeah, whichever one you wire to line one. So remember that these wires can be swapped to switch them, but yes, in the circumstances wired here, it favors line one.
Okay, so then don't we have a recommendation for the customer to always put the utility on line one?
So we receive the one line of what they do. So our line one is implicitly where they call out utility there.
Okay.
There is some question, like if I can't see a scenario where they switch them somehow, because that would invalidate what we sent them. Like the one line that we listed it to is no longer correct. So we're making that determination because they give us the information.
And then if it's generator, how do we pick one?
So a generator is kind of interesting because you want to have your favorite generator on line one, but if you don't have a favorite generator, you don't really have to worry about favoring a source, because in the case of generator, it's gonna pass through line two if line one is off. And if your generator one is still on, it's okay to use that generator for power. So it wouldn't be a bad scenario within our truth table. But I will say this system is kind of set up for a utility generator, but it would work with two generators.
And so again, because I'm the most ignorant, but why would I favor one generator?
And because a lot of times, even in a system that has two generators that you're resting one and doing the other, you will have a bigger main generator and then a backup. So some generator systems are what I described, where you switch between them equally, but a lot of the time it is a
Yeah,
main
so we're
generator.
assuming that the generators are not equal.
Yes, and remember,
There's a main one and a smaller one or backup or whatever.
yep,
Okay.
it can work for equal generators, and also line two is the typical line we see temporary connections on, which is your temporary generator you roll up, which is fully compatible with our system. So that is obviously not a favored source. It's just, if it's the only source, that's what you want.
So how are you dealing with redundancy here? If one of these components were to fail, what happens to them?
So effectively, if one of these components goes dead, and we're gonna go into good and bad here, but
I mean, if we're gonna jump into it later, let's.
yeah, but generally, the system I'm gonna call it fails gracefully in that if you lose power to your controller, let's say your power supply dies, your contactors die, which we're using the same contactors we use in load banks. We're using well-known ABB contactors, trying to keep it well spec'd here, but the controller will go off and it will not change the state of as long as it's receiving power to the end, it's not going to change the state of the breakers. It'll go off. It might even kick up your backup generator, but it's not going to flip you to your power. It's just going to kick up your backup generator because it thinks it's off, and then it will keep your utility power online. So, that is not a good situation, but also having a component failure is never a good situation. So it shouldn't, it doesn't by logical means shut down your facility if one of those things fails. Right? But it will kick up your generator, which is kind of annoying. Which there's a couple, so this is improvement items. There's a couple of ways I've thought up of avoiding that generator kick up that we can discuss. Power conversion, this one's just unbelievably simple, but all we're doing from that 277 volt that we're getting off of those relays and those contactors is we're just converting it to 240 and then feeding it into a power supply to get to 24. We're using 24 volt DC power because I wanted to be able to safely, without energizing the unit with dangerous power, test the unit at every stage. Because 24 volt power is implicitly safe per OSHA. And 240 volt power, which we could do for the entire control system. For all of this, we could do 240 volt power. But I think if I was doing this again, I would recommend switching to 240 volt AC power for the controller and the breaker accessories. And there's a couple of reasons for this. For one, the current 24 volt DC system is connected to the terminals on this controller that is typically used to connect a genset battery to it. And that's okay. I mean, because that's the only 24 volt DC connection. But I would like to, for this generator issue we're talking about, where it kicks up in a failure, I would like to be able to have this thing always stay on no matter what is the goal through the use of the genset battery. So I don't want to take up that slot. Because there's two power supply sources to this controller. One's AC, one's DC. We're taking up the DC one right now, which is also the one you would connect the generator battery to. As well as that, the power supply has a startup time. It's a really small startup time, but so we can't just wire 240 volt AC to the controller and then run the rest off of 24 volt DC. Because what would happen is your controller power comes back, and then it tries to do something to the breakers, and the power supply 24 volt DC that actuates those accessories is not up to be able to, so it would have to reissue the command after 10 seconds or whatever you have to set to. So that's not ideal because the power supply is it's pretty fast. It's 350 milliseconds, but this controller will send a signal within 10 milliseconds if it wants to. So it's just too fast for doing that. And also, this is the biggest thing, the biggest reason is having a power supply power the breaker accessories and this. We spec a $350 power supply. It's a top of the line one. I mean, it's made for this kind of stuff, but power supplies, I think, are too risky to be a single point of failure to turning the controller off. Even the nicest ones, it's just switching power supplies are, we use them in a lot of stuff, but for this kind of thing, I'd rather just run straight voltage to it. And like I said, none of this stuff invalidates the 24 volt unit for being a commercially viable unit that works. It's just when we look at some kind of, failure mode analysis, this would be one of the things to look at as, hey, we should maybe consider running 240 volt AC. But there is some questions with the 240 volt AC system is, when your power shuts down and you're from utility and you need your generator to come up, can it open the breaker for your utility power fast enough before it shuts down? With the power supply, it can, because you have some capacitor time delay. But with the 240 volt AC, logically you wouldn't be able to. But I've been told by Siemens it will. I just don't quite understand why it would, I guess. So we would have to test that. And I kind of do intend to test that on the Acorn Trail microgrid because we have a 240 volt AC system, disconnect the batteries from it and just see if it'll work. But yeah, so I think 240 volt AC is the future for like a platform for this, but 24s works too. It's just, there's some downsides.
And why do we pick the 24 volt?
So simply because of the ability to because all of these units need to have, in my opinion, a power test before they go out.
Sure.
Too much wiring. You're able to test the power every bit of the way without bringing it to an energized state that it could cause harm. So it's just a way, so it's easy. You can just pull up a power supply and test what you're working on right away.
It fits our current QC state.
Correct,
Right.
yes. For a future QC state, yeah, I mean, yeah, that's the main reason. Also 24-volt DCs, it's a nice controls voltage. I mean, there's not a lot of other controls devices that use like 240-volt
Right.
AC power, so it's just nice, common. Oh, okay, so notable components. So this is the components I was talking about, and these are components that are really important to electrical one. Because if we switch voltage, you're going to see some of this stuff is particular to 277. So these general purpose contactors are these contactors I showed in this diagram. They're ABB ones, very similar to what we use in load banks. 2 normally open, 2 normally closed contacts, and they can go up to 680 volts across the terminals. But the coil, that thing that actually opens and closes, is 250 to 400 volt AC. So that's obviously out of the range of any of the 208 volt stuff we do, all of that. And that's because we needed a 277 volt coil, which is pretty rare in a contactor. But yeah, so that's one of them, as well as this voltage sensing relay. This is the upgraded PRM I talked about. This thing can take anywhere from 120 to 290 volt AC. I would say this thing is flexible to any system we do, just because it's so wide range and it's programmable. So I wouldn't worry so much about this. You just have to know that we have to program this per the application we use. And as well as that, the control transformer, once again, voltage transformers are dependent on, believe it or not, voltage. So we would need to spec a voltage control transformer that would work for the voltages we are going. And I shared a document with the meeting that had kind of a BOM that had all of the dependencies for different voltage, current, all of these things. And so if there's a V next to it, it's voltage dependent. So you'd probably have to look at, switching it if it's a different. And that's a Excel document actually. Control panel. So now we're getting into actually integrating it into the unit. This is what the current control panel looks like from the front and where everything sits. We have the fusible disconnect and the fuse holder. And if you're curious about what this looks like more, there's about 4 of these sitting on the floor wired up. So fusible disconnect, fuse holder, voltage monitor. So the power distribution system sits on the top rail, and then power supply down here, control transformer, because it's like 40 pounds, is sitting on the bottom of the unit. And they're impressively heavy for how small they are. And this kind of reflects the full, I would call this box is 95% of what makes this box, and the gland plate in front of it is 95% what makes it high amperage ATS. So it's all compact into one area by design. I promised to talk about the fusible disconnects quick. So quick note on service entrance. We're pulling taps from the utility in front of the service disconnecting means, which is not allowed per National Electric Code in most circumstances, because there's no overcurrent protection in front of that first breaker. We're pulling straight from the voltage transformer you see up front. There are some exceptions laid out in NEC 230.82, which is equipment connected on the supply side of service. And this is where we managed to pull the exception back in November. So the article reads, only the following equipment shall be permitted to be connected to the supply side of the service disconnecting means. And there's 11 examples, but the 7th is control circuits for power operable service disconnecting means, if suitable overcurrent protection and disconnecting means are provided. So this is directly related for what we're talking about. We are making a power operable service disconnecting means. And in our case, the SOCAMEC fusible disconnect I talked about has suitable overcurrent protection for the gauge of wire we use going through it. It is load break rated, which is really important. And these three things are, if we ever need to switch it, these are the standards we have to meet. Load break capable, and it can withstand, and this is the hardest one, 200,000 amps of fault current, because you need it to be rated up to what your enclosure is rated to, which in our case is 65 or 100. So we want it rated all the way up because we're pulling straight off the transformer. And this is a reference from the NFPA. This is 2020 code language. I checked 2023, it didn't change this section. So they added a couple to this article, but yeah. So we have to know that we are doing something that's typically against National Electric Code. So we have to be very strict in how we are handling it within the exception that's laid out within the code. Oh, here's just a couple dependencies. I mean, I just kind of threw these in. There's a much more laid out one for the in the Excel document, but all of the components are currently spec'd for 480 with in a Y connected system, so 277 to neutral. But this is kind of varying levels of difficulty. As you go down, it gets more and more components. So these should be relatively simple. You have a relatively small voltage to neutral, so you can just spec the components to the neutral voltage. These are harder because you don't have a neutral, so you have to find some kind of relays that support large voltage phase-to-phase connections. And these are all implying that they're delta connected or no neutral Y. And then 240, 120 split phase is possible in the controller, but obviously we made a 3-phase system, and running a split phase system would change the control architecture a little bit. But the controller completely supports. I was actually running, I configured one of the ATSs to split phase, and it worked pretty well. So yeah, if anyone was with me for the testing where I put the little leads into the back of the controller, we were running 240, 120 split phase there. Operating mode. So a little look into how the controller itself works, because, if you're working on these, it's good to know, how this thing operates. So there's 3 modes: an off mode, a manual mode, and an automatic mode. Off mode, basically the device will not send a signal to the breaker accessories. It'll meter the power, it'll sound alarms, and you can turn alarms on and off in this state, but it will not change the breaker state no matter what. This is the only state that the controller can be parameterized in. As well as that, we have manual mode, which is kind of exactly what it sounds. So you directly input your what you want in the controller. So you go there and click open breaker 1, boop, it'll open it. You do, a start generator 1, it'll start it for you. So yeah, and those are all on this, for those who are on the call, you can see there's a little screen up here. This is kind of what it looks like on the controller. That stuff lives right here. And you hold down the button for about half a second and it'll flip to that mode. Automatic mode is why we're making these things. It's just lets it go, it lets it go wild with all the parameters you set, and it makes the decisions. So, and it'll sound alarms. It'll do anything it sees fit based on your parameters. We kind of went over this already. This is just how you parameterize it. This is like the manual way of doing it. This is also in the documentation, so I won't bore everyone with going through like how you actually get into the parameters. It's just follow these steps. Very, very simple. This is probably the way we want to do it at volume, because no one wants to be just sitting there going through each parameter. You could mistype something. It's just sloppy. But we're getting one of these cables. We should have it within like a week or so. And this will just let you power config on a software, and yeah. Oh, mechanical design, cool. So mechanical design, there's not like a whole bunch here, but there's Chris sits up in his seat. So this is your your not isometric view of the control panel, and this sits basically where a breaker riser would in our typical unit. So you can see it on the right here. It slots right in, and it uses the what are those things called on the unistrip? The little
Thin wrap?
no, the little things you put the bolt into.
The strut nut.
Strut nut, yeah, strut nut. So they bolt into the strut nuts. And so this is kind of a all-inclusive. You can pre-assemble this separately and you can just kind of plug it in there. And then you have a couple, you have your switch that can disconnect your utility control power, and then the controller sits on there too. So everything is kind of in that little area right there. There's a couple things that, I mean, some of this mechanical design is where I wish I could have done it better, because like, I don't know, it's just, there's some stuff that is very annoying to put in. The one thing is that the voltage monitor, which sits within the panel, I would like to mount like we do the PRMs. And what that means is I'd like to have it on the gland plate so you can program it without going into the panel. Because in the current situation, if you want to program something on here, like change your main parameters, like voltage or frequency, which shouldn't be done very often, but if for some reason you need to do it, then you'd have to go into that panel and reconfigure that to match this. I would like them right next to each other, right on the panel. So that's a definite improvement item. As well as that, a hinge door rather than a gland plate. I mean, pretty self-evident. Like a hinge door makes it easier to wire without causing wire strain, because you know how it's going to be opened. As well as that, it makes it a little more accessible. I mean, we can lock it still, but it makes it a little more accessible, as well as it makes it just easier to build, easier to wire, all of those types of things. There is a
Jack?
note, you want it locked. Oh, did I hear?
Okay, it's got-
Yep, sorry, just a quick question, and I think I already know the answer. We haven't had the opportunity for any VOC on any of this stuff, have we?
No,
Wait,
we have
okay.
not.
Okay, just curious.
No, we have not. Yes. And so, yeah, this is, I think the hinge door is pretty nice. The one thing is, if we make a hinge door, it's got to be under lock or some kind of, difficult to access means, because we have 480 volt power in our control panel. I mean, it's not a typical control panel. This is the dangerous control panel. So, you definitely, the gland plate's nice because it's difficult to get in, but it's just difficult for everyone involved. We want to make it accessible for those who are qualified, but not.
Like UV print for it and stuff.
Yeah, so this has some special UV prints on it, which is there's one that sits underneath this little handle here, which says voltage will still be present under generator power. And what that means is, if you flip that switch and go into that panel, if you have your generator on, that panel still energized with 480 volts. And also the utility top side of that switch is always energized with 480 unless you disconnect at the transformer. This, I mean, it makes sense because this docking station is the first disconnecting means in the entire system. So you'll always have voltage present, but there is special UV print that sits on this plate that makes people know that, you need adequate PPE, as well as you need to triple check with your voltmeter, because there is voltage here.
Are we labeling this piece of equipment anyway? I mean, the big unit, are we putting a stamp, a label, a sign, something on it?
So are you talking like a sticker or something to?
Anything to convey critical information to the user. So, for example, do we need to communicate on the unit a limited space and a restricted space?
Yeah,
Confined space.
so this, if you see here, this is a picture of it.
Uh-huh.
It is flush full of stickers that say like all sorts of different, whatever is we need for our 1008 listing, as well as the, the whole list that we have for our safety and standards. I'm not sure.
Well, it's just, I'll just show off. We just recently had the NFPA 70 training,
Yep,
correct? And in the examples I remember, they had a label on the piece of equipment that very clearly said restricted space and give you a distance, and limited space to imply when you needed PPE and things like that.
arc flash ranges.
Yeah. So since you're saying there's a condition under which it could still have voltage, do we need to label it to communicate that?
I don't know the exact labels you work in UV print. Do you know the exact labels we have on our panels?
So we have 3 different styles of danger, which are the ones in red here. All gland plates that are removable have a high voltage reinstallation required. The unit is re-energized. The others go to more towards the UL 1008 items. So each gland plate there has the reinstallation required. However, the ones in yellow also convey other cautionary items.
But we don't really
Not specific.
articulate those distances.
No specific distances.
Yeah, we
And if
don't-
I close that door, what do I see as I walk around? What kind of stickers do I see? What kind of labels do I
You'll
see?
see the reinstallation required on all the sides. So anything that's bolted on will have that reinstallation required outside of the cam lock glands, simply
Uh-huh.
because to take those off, you have to remove every single cam lock.
Mhm.
The door itself has the required UL 1008 warning, electrical shock hazard, and all of the cautionary items in red for each door for deluxe pad mount.
Okay.
So in this, I want to clarify just the control panel when you go into it is, it has some voltage present, but the unit itself doesn't pose an additional arc flash barrier hazard to any of our pad mount units that are the same rating within the same thing, because that's determined based off of your available fault current, and this won't have any more available fault current than your standard pad mount. So if there is a consideration for needing that labeling, it would be across our entire pad mount line, if that makes sense.
How much would a customer have to get inside that control panel once it's installed?
Ideally, never.
Kind of what I figured.
If they want, ideally never. And if if the voltage sensing relay goes to the front panel, even more never. Because that means if their nominal voltage changes somehow, and they want to let's say we have really spicy voltage here, like 510 instead of 480. Let's say our utility provider was like, oh, you're getting 470 now or something within the same acceptable range, but you've dropped 40 volts. You want to set your nominal voltage down. They would have to go into that panel to set that down. If we move that thing to the front, only under a equipment failure or a component failure would you ever have to access that panel.
Mhm.
Yeah.
And so if that were to happen, is that labels there saying call TriStar?
I mean,
Not necessarily. There's this white label on the door.
Yeah.
That is a printed plate that's bolted to the door so it doesn't easily fall off. That has all of our contact information on it.
Yeah, but if that unlikely event happens, are we comfortable with the customer just having at it on their own?
depends on who the customer sends in, but a lot of our customers will be working on their unit energized, or, it's just the same as any support call.
It more than likely be a licensed electrician that is
It
working
would-
on the unit or in the unit at pretty much.
It would be legally
And so
required to have a.
So there's no extra risk as long as you have a licensed electrician, is that?
I mean, it's still risky, but at least he's a licensed, knowledgeable electrician and is
But to the
licensed to be doing
I
that
think
style of work.
point that you're trying to make is that if someone has to go into that enclosure, do they have all the equipment, all the knowledge, even if they're electrician or anything like
Well,
that? Do they know?
so partly, I'm not smart enough to be able to articulate the question well, so thanks for helping me, Jake.
Right.
But I think it has to do with safety, but it also has to do with warranties. Certainly on a warranty side, we don't want somebody using screwdrivers, whatever the hell in there, and then all of a sudden claiming something malfunctioned later.
Mhm.
So how do we communicate those things, or do we need to communicate those things? I'm asking, I just don't know, but.
See, to me, it's like, so we can disconnect power. I'm gonna assert that if there is a consideration for this, there's a consideration across our entire line, because this to me doesn't seem very different than if you had a power failure on a power supply for ERMS or something.
Well, you're
like
making a risk-based statement, which is probably acceptable if there's no safety risk. So what I've heard is, because we have been selling pouch mounts for a long time, okay, and you're repurposing a pouch mount deluxe enclosure,
Mhm.
correct? And we haven't had that issue before. The risk that the issue comes up is very low, and if it happens, because it's gonna be done by a licensed electrician, it's even lower to safety. Now, to warranty, different question, that's a business question, but to safety,
And there, yeah, and there, I mean, when it comes to safety, there is a safe way to do it. You call your utility company, and this is the correct way to work on one of these units, is you call your utility company and you have them pull the transformer. You have them pull the transformer.
and that's what the electrician, licensed electrician would do. And then, okay,
Yep.
so forget the warranty side, which is still a concern for me from a business standpoint, but what you're saying is, it really, we have been selling these for a while, it hasn't happened, so that risk to warranty is very low. And the risk to safety, there are mechanisms to mitigate that through the actual service call, even if it doesn't involve
Yes.
us.
And if you go there, like, let's say we send John out to go and work on it, this fuse disconnect, his process would be you disconnect, you close or open both of the breakers. Let's say you had to work on it energized. You close both of the breakers, you go to that main switch, you flip that fuse disconnect, you make sure the generator breaker's open, which feeds this power. Then you check with your multimeter, you go through the entire process. The only point where you'll have active voltage in this box is on the top side of your disconnect, because you can't I mean, it's just there because it's coming from utility. So this is the only point. Everything downstream, it would not be energized. Of course, you have to go through the process.
Yeah, but we don't have to trust them if you just measure the standard they're supposed to follow. Calibrate,
Yep.
measure, calibrate again.
Yes.
I know there's a different way to call it, but make sure it works. Measure where you want, make sure it works.
Yeah, but with like, I don't want to there's, when you're working on any pad mount, there's risk, of course, I mean, there's always risk when
Well,
electricity.
add it to the list. So you have a list of potential improvements, add it labeling it might not be necessary, but add it to the list of considerations for a second generation, okay?
Mhm.
Since you have many other things to say, should we be communicating these things differently? And maybe it's at the bottom of the list still.
Yeah. Awesome. Yeah, so I think that, yeah, those are the improvement items plus the one there. And I think, yeah, and I would say a lot of these things are pretty minor. Like, they're not like minor in that they're not particularly difficult to do. So I would say they should be done sooner rather than later. But that's just me throwing my opinion in there, not.
As soon as the next order,
So it's tough because the next one's DPass and we're ready.
but we don't have time to do
But
it.
I would say any order.
As soon as the next after the next.
Yeah, yes. I mean, even we'll go through the quote for the 2500 amp unit.
Uh-huh.
Like, I would even start doing it for that.
Then not, because we have another order there that is not DPaS.
I would recommend
So that would be a place to, okay.
implementing those. And I'm not here, like I said at the beginning, this is supposed to be a technical review that gets everyone up to date on the technology. I don't know who does it. I don't know how, but I mean.
Well, we discuss that
Yeah,
later in
yeah,
the context
that's
of the active project.
Yep. Absolutely. So here's our one-line acceptance criteria, and this would be much more relevant if, well, it actually is relevant because we have a couple of the folks who do submittals on board, but this is especially for the electricians, is there's basically 3 acceptance criterion for the one lines. The breaker's in a position that works as an ATS. So we kind of discussed that ad nauseum at first, it was that little diagram with the source 1, source 2, there, that has to be in there somehow, right? Yeah, so source 1, source 2 breaker with a load in between. As well as that, one line is electrically safe and logical. I mean, when you look at a one line here, you wouldn't even be able to tell it's an ATS necessarily. You can ignore the fact that it's an ATS, as long as these are mechanically interlocked, which it shows here. The rest of it just needs to be electrically safe like we do any other one line, and it needs to be able to fit in the enclosure, taking into account the control panel. As long as it's electrically safe, interlocked, logical, we can add you can add dual purpose, all of that kind of stuff.
Well, so this diagram has one permanent load, I'm gonna call it.
Yep.
Even though it says output, and then 2 and one temporary load. But what you're saying, and that was not in your first drawing.
Yep.
What you're saying is because the T at the top, middle top of the diagram, the T is there, that's the source one, source two, and load, the fact that there's another temporary output doesn't matter because it still fits the scope of our work.
And this one is interesting. That temporary output's yes, I'm saying that, but also that temporary output's a load bank connection. That's a dual purpose thing. So this has this has two generators that are possible. One here,
Yeah.
one there, right? They're interlocked, that's okay. But yes, that T makes it, but there is a consideration where it's like, if I thought long enough, I could come up with edge cases that might say, oh, you have a T in this case, but it might not work. But that's kind of the purpose of this training is whoever's reviewing these one lines needs to understand how the ATS works and make sure it's safe and logical.
So, yeah. So if this is still new technology, as we see them, if we ask before accepting, correct?
Yeah. Absolutely. And that's one thing, I don't know if Scott's online, but it's kind of the submittal process looks like, I think it would be prudent to have an electrical resource review these before they are accepted. Because we don't do that currently, right? I mean, you could ask a question, but
you can ask questions.
So I think that is the way forward with these. And I think, we're training and I can assist with this, but both Steve and Jesse, and I'm sure Mitch after a while, would be able to tell it just as well as I would if it's okay. They know the ATS pretty well, so.
Yeah, but there's a middle process that's past sales, correct? So because I think a lot of these things need to go all the way up to sales somehow.
Yeah, some of it, yeah. I mean, and this is where I don't know how much I understand the intake process, but when I was working on some of those way back, that was before acceptance of a quote. Is it still that way? Or do they sell stuff before we even have a look at the stuff?
Oh, I think
No, that's how we got here.
Well, think about the nature of where this project came from.
Yeah.
Correct.
That's really where
Because I guess if they're selling like the stuff we're conveying now, I don't feel confident that we can train the salespeople, but we need to have.
No, it's not a training solution. It's a work process solution.
Work process, yeah. That's what I'm saying. It needs.
And I'm asking because I need to come up with one and vet it with people. So I think you're asking for something before submittals, really.
Yes.
Which makes sense. I'm trying to understand where you're coming from.
And then, if we have, and I promise not to process this time, but now I'm getting into it. If we have some of these, like, let's look at a 240, 120 split phase, that to me is like ready for what is currently the power design board. Like when they get obscure within the thing, there is some level where it's like maybe that needs to be routed to a resource that looks at it closer than.
It's called the discovery team.
Yeah, the discovery team. Yeah.
So is your comment with like having that electrical review, kind of making sure that at the submittal stage, kind of making sure you go through these things as far as the one line is considered?
I think it's very kind of from a simple perspective, mechanical resource, SME, it doesn't have to be SME, mechanical resource, electrical resource, look at it, approval before sale. That's all, it's one line and quote, and we'll go through a quote later.
And that's how anything can be. I agree that these in nature are what I would call are in a regular order execution workflow as a custom unit. And so, pretty much all of our custom units should follow that same process. If it's something that we haven't seen or haven't done before, it's different enough where it's not going to discovery, but that stuff needs to be looked at in the front end because we deal with a lot of pain of we get something and then it turns into an order and then we try to figure it out. We should be figuring it out before we actually sell it.
Well, yeah, especially because you're saying electrical and mechanical resource, and maybe one of those resource does this too, but there needs to be an estimating resource for timing and all of that stuff.
Absolutely.
We shouldn't just be copy pasting SLAs anymore.
Absolutely. I'm sure with these statements we're making, we're probably preaching to the choir.
Oh, we are,
You know, I
but
mean, yeah.
we're preaching to the choir, and maybe I started to open this kind of worms, but I just wanted to understand where you were coming from, because it feels to me that the solution is a little further upstream.
Yeah, and I just, the reason I emphasize it with this is we have a lot of people who have a lot of expertise in their standard pad mounts, and they know the tricks and there's just a lot of traps you can fall into these that are very marginal, you know, like that that a person reviewing submittals who inexperienced could let through more easily than a standard pad mount. So that's where I sit with it.
Okay.
Oh, here we go. Here's for our sales folks, required quote information. So first thing I want to say is this is not like, oh yeah, we can do all of this. This is like our platform. These are questions that the sales force, we need them to ask to understand the unit. And some of these things have a little trick in them where like open and close transition, we can only do open transition. But in the past, when I've asked for that, they'll just say, oh, it's open transition and not ask the question. So I want all of these questions answered, even if the answer is it's outside of, or it's more of a challenge for the platform. So voltage ampacity, we already do that, obviously. Availability of the generator battery and generator battery voltage. So this goes into the new rev of the design as we're working through it, which we want to utilize that generator battery to keep it up. We need to know the voltage of it, and we need to know if it's available. So yes, no voltage. As well as that, type of connection, need for RJ45, we could call it like Profinet or Modbus, but that's just the connector in there. Service entrance rated, it doesn't really matter if it's service entrance rated or not, but it'd be nice to know just because we're kind of towing, or we're not towing the line, we're using an established exception, but it'd be nice to know, as well as open close transition. And then full riser diagram to review, just so we know the context of the build. So these are questions I'd like to see on every quote that comes through.
What's the purpose of the RJ45?
So I see on some of these quotes where it's like additional communications needed and all of that. The RJ45 basically is an adder you can add to the ATC module in the back. So there's these two additional slots. It lets, whether it's through Modbus, Profinet, any of those types of things, Profibus, it lets you access all of the registers of information connected to SCADA, whatever, supervisory control. You can just plug a Ethernet straight into it, and it can push all of that. They can connect it to their network.
Is there any reason why we wouldn't consider that just standard?
Expensive, even for us, very expensive. The list price for, and this is going to sound absurd, the list price for the Siemens part is $9,000 just to add Ethernet to this. We get it for $1,500, $2,000. I mean, the list price for this controller is $12,000. We get it for $1,500, but still very expensive. That's the reason. Yeah, it's
So what is a full riser diagram?
a full riser diagram. It doesn't just show what they want for their one line. It shows the entire system outside. Are they bringing it to a switchboard? What are they bringing in? What kinds of generators? All of that stuff. It shows the full building schematic, which I think we should be getting that for every single build we do anyway.
Okay, good. In our engineering design guidelines, we call that the block flow diagram.
Yep.
So maybe we might want to, I need to think about including that language there, because I know what it is now,
Yep.
but I never heard those words.
It's basically the blueprint for the build, the electrical build.
Yeah.
Yep. Yeah. But
If you're saying it's this critical, right, that we need to know where the generator and utility play,
mhm.
Based on the controller schematic, then I think that's required. That's a recommendation.
And it's nice to know. I mean, it's nice to know for us too, like what is this at? We can give recommendations. Is this at like a mining site with horrible power quality? Is this at a hospital? Like what? There's just controls considerations that I'm not saying there's direct cause and effect here for building a build, but it's nice to know just so if there's some marginal thing we need to know about,
And it seems like if someone is speccing this, if some contract engineer is speccing this into a system, that they should have.
Yeah.
Right? That's not just gonna be something that they're playing with.
Exactly.
So imagine you're processing one of these orders. Would another question come to mind? For any of you?
Not offhand, I mean, the biggest things that I would have questions for is when they're trying to fit stuff, you know, I mean, we say the ampacity is up to 5,000 amps, but if we actually do a 5,000 amps, you're not gonna fit it in the same form factor that we use on these previous ones in a deluxe pad mount, and have to go to like a triple pad, which then you're doing some different stuff with bus bar, but I mean, the controls and everything that Jack kind of described on, you know, on how that system would work would still, I think, be the same, so I mean, I don't really have any other.
But you have, if you have that answer, I say I want 5,000 amps.
Mhm.
You still know what to do? Or do you need more
I
information?
would say from a mechanical standpoint, I would say I would need some more time to understand the actual controls and the electrical portion of it, but that also becomes a question of who would be doing that role going through execution. Is that gonna be an electrical engineer? Is that gonna be an electrician? Is that gonna be a mechanical engineer who has that ability, I
I
guess?
don't know that.
Yeah, so,
We're trying to bring up the questions though, so that's.
yeah, I mean, looking at this, I think most of the stuff makes sense. I don't see anything blatant on here, but
Okay,
My
what about you,
curiosity
Chris?
would probably be handled more in like the electrical review side, because I guess I'm curious about like breaker adder stuff. Like, are these like inherently LSIA breakers then, since they have bell alarm as part of the design?
Well, so they're not, no, they're not inherently, the two separate alarms. So that's a ground fault alarm, and the bell alarm is just an indication contact.
But
They're
they
not
could still be
inherently
spec'd as
LSI.
LSIA or LSIG or.
So with these units, it's kind of fun because they're high amperage implicitly, right? So per electric code, they're all gonna have ERMS and LSIG on them anyway, because NEC requires ERMS and LSIG over the ampacity of like 1,200 or something. So they're all gonna have it because they're just high ampacity. So
And then I'm also taking away that there's not gonna be a 4-pole version of this.
they're okay. No, so
in the backlog.
they're
We can't fit
it's
4-pole in the deluxe stuff.
we sold one actually. No, so they're
I don't think we can fit 4-pole. Can we?
It's gonna have to
Depends on your
4-pole
amp.
frame size 3.
well 2,500.
Okay.
But it's gonna have, I mean, we could there's no reason we can't put these in dual.
Okay,
pads.
but hold on a second.
If we were,
I don't have a clue what you're talking about. But is there a question that should be added here regarding 4 poles? Whatever that means.
Well, just whether or not it can be made or sold, because 4 poles are a request you get for.
It's
transfer
already,
switches.
yes, it's already,
Yeah. Part of a standard docking station.
Oh, okay. So it's already a question being asked and these are in addition. Okay.
so now I get to show off this thing. So I actually designed this with 4-pole in mind because I switch neutrals here. So we can 4-pole, and I'm gonna help process that 4-pole quote, but 4-pole should work because I'm not just taking the neutral from the common neutral. I'm actually taking it from both places and switching it through the contactors. So I have it kind of set up for 4-pole already. So
So it's just a matter of whether it will physically fit.
yeah, and I do hope, I mean, yeah, there's a lot of stuff with electrical here, but I really do hope we see, and I don't know, I mean, I'm not a supervisor nor a, but I really hope we do see a lot of collaboration between the mechanical and electrical team on this and really have both sides understand both, because these units, it's kind of a get them, dance to get them working together. So I'd like both sides to really have a strong understanding of what's going on here on both,
Well, that's the piece of some of the stuff too right now is that, we have electrical doing some of the electrical review and the mechanical doing the mechanical side of it, but not every mechanical necessarily does a second over electrical components. Not everyone knows the breakers part numbers or all the accessories or that stuff. So a lot of the times you're just trusting the electrical. Some of the mechanicals, if they have more experience, they're able to look at certain parts and be like, okay, yeah, we do need that, we don't need this, and can kind of question the electrician and do a full review. But not every single mechanical engineer can do that since
So
we
it's
are.
not like in an
downstream.
ideal case, like at least I'm thinking genetically, not even if it makes sense, business sense or anything. It sounds like ideally we have, let me assume electrical design first, mechanical design thereafter, but then system review thereafter. That's what it sounds like. And are we doing that today or not?
No, I mean, it's pretty much electrical, mechanical, and then mechanical is the one who releases it at that point.
Oh,
Yeah,
and
there's-
and God help us. Okay, so as things get complex, and I guess I'm speaking out loud because I know Scott is here for us to think about beyond the IT, when we do customization, I think we definitely benefit from some sort of assembly line type of approach where, let's say it's electrical, mechanical, but then system review. But somebody has got to be looking at the interaction of the two, which I think is your point.
Yeah. In the end, a lot of us are, I'm a
And
mechanic.
I don't know anything about this, but I can tell you from the chemistry and pioneer side, yes, you don't do that, you're gonna pay.
Right.
Okay, so
I've
that's
heard
a
people just take
consideration
Jack.
for our organization. Well, the organizational aspect, how could we improve in this process? Well, it sounds like as we go into more complex systems, we need to have a system review.
Mhm. Yeah, you need someone to be able to review it all together, and right
Yeah,
now, not
yeah.
everyone can do that, and like with this, Jack's the only one at this stage, he's trying to get other people
No,
to
but
be
we
able to
don't
do this.
necessarily want everybody to be able to do that.
Right.
We want somebody who we know can do that, or
Mhm.
2 or 3, however.
We just need those people.
So as you remember, we're talking about systems and workforce planning and things like that, Samantha. With the little I know already, that's a massive opportunity for us with the little I know. So we keep working on that. Let's think about if there's a way to justify it, because perhaps we got away with it in the past because, there were things that even people without engineering degrees were putting together, correct? But that's not where we're going. Somebody needs to do a systems review.
In the end, we have mechanical engineers. I'm a mechanical engineer, but we make electrical systems, and it's a good idea to at least have some background,
Somebody needs to do the review, because eventually it's electromechanical review in this context, but at some point it might be soft electromechanical and control systems, the whole damn thing. Somebody needs to look at the whole damn thing. So I'm sorry, I did not mean to take over, but I'm interested in what they're saying. So any extra questions you would have from a customer?
No, I think Jack did a really good job covering the different type of opportunities and stuff that would arise. And yeah, taking it as like a step-by-step approach, I think is crucial.
So with this list here, you're assuming all the stuff that's naturally on there is already on there as well?
Yeah, and I might have confused that because I put voltage and ampacity on there, but I just wanted to kind of show what I'm thinking.
Are those the only voltages you can do?
Well, it's like I said, it's
Thank you, guys.
it's the pyramid
Yeah.
of doom where it gets harder as you go down. But yeah, you can do them all. It's just how many components do you want to switch, right? The controller supports medium voltage. The controller supports anything you want to, but it's just, yeah.
Does the voltage monitor in this replace the standard voltage monitor, or is that still there?
No, it doesn't replace it, but so the PRMs we use now, is that what you're referring to?
Yeah,
The
I'm
phase
just wondering,
rotation.
like, are you going to have a phase rotation monitor in addition to this unit?
Yes, because it's in there already, but it's in my opinion, we don't even need a phase rotation monitor in any of our units because our breakers
breaker
can
do it.
do that. That's not but yeah, we'll keep it in there because there's no changes that would really, our breakers can do it, our controller can do it, but that hasn't stopped us before. So from keeping a PRM in there.
So
Thinking if it
you're
replaced
okay
it,
then.
then if you could move it from outside of the box to where the standard phase rotation monitor is, that solves your other problem of wanting it forward facing.
Yeah, no, that's a good point. I agree. Yeah, you could definitely, or at least mount it that way.
Right,
I like
yeah.
that mounting. Yep.
So Jake, I know you're not in order of execution, but would you have any other questions or answers from a customer, or maybe from the internal teams to think about platforming, because we are repurposing enclosures, correct? So
Right. No, maybe not so much on the quote, but when they hand off that riser diagram, it would be, where is this item going? Is this item in a highly vulnerable location? There's a few things about control systems that we haven't expanded on yet here at TriStar, such as cybersecurity and other items of it. So understanding maybe some vulnerabilities ahead of time would be interesting as far as accessibility to the unit.
I don't have, just my commercial cells, what they sell, right? But it's like, if I were in that position, it's something where it's like data centers and it's like the critical facilities, like hospitals, maybe you wait until our product line is a little more mature, in my opinion, but yeah.
Well, but you're an engineer, you're not a sales guy.
Exactly. That's why I
So
prefaced it
no,
with
no. So I mean, let's not, I agree with you, but I'm not gonna throw them under the bus because our salespeople have a different set of pressures.
Yep.
And we guide their behaviors with our metrics and our processes. So if they're not behaving a certain way, I will first blame the metrics and the processes, not the people. And our processes for sure need help.
And that's kind of where I kind of snuck it in a little bit with requesting a riser diagram
Yeah.
before we accept it.
Yeah.
Because then it gives us a decision, like, I don't know how we're gonna make the decision, I don't know what decision we're gonna make, but at least we know the context.
Right.
What we're gonna do with that?
Yeah. Yeah, and so that's a way of helping them, the salespeople, make better decisions with a process and tools that allow them to do that. But as of right now, if there's any blame to do, is on us, not on them.
Agreed.
So, Hoffman, Samantha, do you have any extra questions? Imagining that you're processing an order like this?
Oh.
We're about to do just that.
Yeah, I don't think so right now.
Imagine we're processing.
And it might be an iterative process. We keep doing it.
It probably will be.
If we keep doing it and we learn like,
Sure,
okay, we
sure.
always really.
But nothing is obvious at this point.
Nothing is obvious.
Okay, thank you. Thanks for indulging me. I just wanted to hear from each one of them.
So now,
An image from the back.
Anybody on the phone, like Jared?
Connecting them.
Jared's on the phone?
I think we have 6 people on the phone.
Oh, 6 people. I only heard Jared and Scott. Jared, any extra questions you would have? For the
I got
sales
bored. I got
customer?
bored and quit listening.
I'm sorry, what?
You said you got bored and quit listening, sarcastically.
Okay,
Bold assumption.
yeah.
So are we looking at making some of these improvements you're talking about making, like the swing door to access it, stuff like that? When are we looking at doing that? Who's doing it? I guess that'd be my question.
Well, let me answer that question. That is something we need to discuss with the product owner. Because as cool as we think it may be, there needs to be a conversation with the product owner to say, hey, this is what generation 2 looks like. Do you see it worthwhile to invest the resources to do that in the context of your future sales or not? So it's not necessarily a technical decision. It needs to be technical and commercial. So we'll answer after we talk back with Christian.
Okay.
It's part of the project. When we go in the project and we make a presentation, there's suggestions for further work. And at that point, the decision team will probably think, okay, instead of closing the project, why don't we keep going or not?
Is there something here though where I get we released it to a commercial product, but like, is there something here where engineering maybe holds a little more ownership over that because of the fact that we effectively had our alpha, beta, and prototype build be the
No, because that was a business decision that was already made water under the bridge, and we need to support that decision.
Okay.
We need to cross-functionally decide that because any investment in resources means that we're not going to do something else.
Mhm.
Okay. And so if we're going to say, yes, we're going to do generation 2, we're saying no to something else.
Mhm.
And that's something that the commercial team needs to buy on.
Yep.
But we have ownership, and it is through that conversation. Otherwise, we're going to get ourselves in internal stakeholder trouble because we're making decisions in vacuum.
That's fair. Yeah.
So, but we were part of the decision to skip the prototype stages, okay? So we cannot back on that. We were part of that decision, and we said, yes, it's okay.
Yep.
So for us to say now, oh, by the way, we didn't have a prototype, let's go back. No, that's not right.
Okay.
Yeah. But we definitely needs to bring it up, you know?
I just always worry about, like, these are like relatively simple changes, and I get it should go through that process. They're relatively simple changes, and I always worry about like the infamous, like,
you know
TriStar
what? You know what
circle.
I've learned? What I've learned, because I used to be like you, If you leave it in the hands of a technical person, nothing will ever be done.
Well,
It will never be
I
over.
worry about the opposite. I worry that we want to make these two little changes and then it turns into like a
No change.
platform effort that.
You know
I
what?
don't think it.
No
is.
change is little. No change is
I
little.
think what you're looking at there is larger than. just-
No change is litter. So I would, especially when you're the one involved in the design. So I would say it's a cross-functional decision. And if Christian says this is an integral part of our portfolio, we're growing like gangbusters on it, then it makes sense and we invest. Otherwise, you let it go and you move on to the next one. Because nothing is ever done. Nothing is ever done. You can just keep sharpening that pencil until the cows come home.
That's fair.
But let's bring it up in the stage gate review.
Oh, since we talked about like if you were to go through a quote, I brought up a quote that's in our backlog and I wanted to go through it with everyone to how I would look at it. So in our case, yeah, so up here, DBGS 20 dual breaker docking station with service and tray utility breaker. That all looks good. Don't really know why it's 20. That's pretty aggressive because we only have like.
I wanted to mark it separate because it is technically the transfer switch, so I
Oh,
wanted
you
to,
push
when
it
I
out?
did it, yeah,
Okay.
I like pushed it out, so I like knew, okay, DBS 20.
Yeah,
is
because I was
when
like,
start my ATS.
looking, 7, 8, 9, 20.
What are
Yeah.
you talking about? You inserted the hyphen?
No,
That's
the,
the one line code.
that's the
Oh,
purpose
yeah.
code in
Okay.
Also,
conductor, yeah. one
Gotta
more.
do this fast because my laptop might die at any
Can you use
point.
your charger?
And mine, when I plug it in, it dies, so it's
Safety feature.
safety feature.
When it plugs in.
You plug it in and it does.
Yeah.
Nice. Okay.
Got a shunt trip.
It's got-
Nice. So your point to process the current order now as an exercise?
Just looking at
Yeah.
kind of some red flags, some good stuff, some bad stuff. So Kirky door over temporary connections with a DBS 20, that's what you have. So it's just this one line. That's good. We should have a Kirky door over that. Oh, I clicked the wrong one. Permanent output breaker, 2500 amp. That's well within our line. There's no major concerns there, just different breaker size.
By the way, thanks for defining what that K is, because to me, in my diagrams, that's a thermocouple type K.
Yeah, ours is a little Kirky.
Yeah. So other than measuring the temperature there, okay.
That's funny. So this one, which is awesome, 48277. And we talk about other voltages at this level of ampacity, we see them, but like voltage code 5, the voltage code we designed them in, 48277 is very common. So that's a green flag. That means that it's the same voltage as the pilot units. ETL listed to UL 1008. I just put that in red because it technically hasn't passed testing yet. It's at Intertech right now, and Steve will be there next week to conduct testing with the Intertech folk. So for now, I mean it does not have a letter of I don't know what they call it exactly, but you have letter of acceptance into. UL 50 is fine. 65 KAIC, just our standard unit KAIC rating. If that was higher, like 100, we still are covered by our 200 KAIC disconnect. And then not really relevant. Those are just very, very standard callouts. And then here we go, integrated 4-pole automatic transfer switch. And you kind of stole my thunder a little bit by
Thank you, Chris.
by mentioning this ahead of time.
Gotcha.
More questions till the end, Jack.
Yeah. Make everyone wait. So, I mean, effectively, this is kind of like a red flag because as you said, like, I assume this wouldn't work. I mean, you instantly assumed it wouldn't work, and it is designed for it, but there is some considerations to look into. Just have someone look over the electrical stuff to verify the connections with the 4-pole. It's designed for it, but it's never been tested. So maybe it's a test phase thing for 4-pole. But that is something to look for, is the different poles of breakers. All of these, I mean, these are all the correct connections. This is these are part of the very standard quote. So there's nothing really to bring up here other than the 4 poles. And then this is where it gets interesting, the S's. So just more of our more advertising stuff. I highlighted in green extra depth deluxe pad mount. The deluxe is the best pad mount to put it in if it can fit in there. But I was a little curious about 4 poles in like 2500 amp 4 poles if they fit in there. I don't know.
It should.
They should, okay.
Yeah,
It's been a
reasons.
minute since I've,
Still frame size too, right?
yes,
2,500?
yeah.
Yeah.
Um,
I know the three can't fit.
yeah, so extra depth is awesome because it fits in there, or in the deluxe, it fits, so that's a green flag there. Obviously, we can do it in any of our pad mount units. It's just a matter of where do you put that cabinet? Do you design a different size cabinet? You know, and I outlined that a little more in the documentation.
Did you just say that if it were 3,000 amps or higher and 4-pole, it would not fit?
I think is it 3,200?
30.
3,200.
Frame size.
Frame size, it's our frame size 3, 4-pole won't fit in the deluxe pad mount. It's too.
How are we specifying that to say no, because that means we're gonna have to redesign the enclosure?
That's within our standard process.
Okay, so it's already there. There's already a way to filter that.
Yes. Yeah, I mean, that's already, yeah, that's even.
That's already with the pad mount.
Yep, a non-ATS unit, same thing. It's actually,
Okay.
and we don't really have anything that supports a frame size 3.
No, get dual pad.
Yeah, so you have to add pads and, yeah. Or hopefully the pad mount 2.0
So from
deluxe.
that viewpoint, nothing new then.
Yes, nothing
Okay.
new.
Or at least the 2.1 deluxe.
I'm just saying, you can do your frame size 3, 4-pole in a regular pad, but not dual purpose would be the issue with it.
Yeah.
Right,
Yeah,
but, and then your cams, the next issue should be a 14 cam.
you'd have a tough time fitting those in a regular pad with the control.
Yeah, so
You're dual pad
Be part of your size considerations for it, but yeah.
Yeah.
That's why I was asking part of this when we're looking at it. So here's the extra required stuff when looking at like the high amperage ATS portion of it, but then there's still all of your general docking station information that we'd have to look at, like does it fit? You know,
Yes.
that type of
And
stuff.
does the enclosure need to be inside the pad mount for the controls?
Could you do it on a wall pack?
I would not recommend that. You could, but it just,
What do you mean? The little box that you ingeniously
Yeah.
put together, could that be outside?
you could do it as a wall pack, but you would, if you go out and look at one of those things and just look at the wiring, there's so much wiring. If it's a long way away.
Well,
it just depends. It just depends.
Take the solution aspect out, can it go outside?
Yeah, absolutely. Well,
Are we
well,
calling this a wall pack?
I want to say, yes, it
Just never
can
heard wall pack.
technically, code wise, I couldn't
Okay,
tell you.
Backpack?
grub board.
So then we have normal/close auxiliary contacts on transfer switch and circuit breakers. I put this in red because we might need to redo the nomenclature. We do have auxiliary contacts we can program on the transfer switch, but that's kind of weird. That's weird phrasing for our transfer switch is our breakers in some regards. So we don't, typically we have the ABB one, which has auxiliaries, normally open, normally closed. In our case, we don't have that. So this phrasing is kind of wrong. These are very standard. And then going down here, this is where it kind of gets interesting. Just a bunch of normal adders and then the 3-wire auto start and diverter switch with indicator lights. So I don't know too much about this thing, but one thing I do know is that we have on the ATC controller remote auto start functionality coming off of 22 and 23. I have it programmed. So this is a normally closed contact. So when the controller shuts down, it starts up the generator by design, because if you lose all power, you want your generator to come online is the concept. How this would work with a diverter switch that goes to temporary connections, that needs some looking into, because I don't know too much about the the line diagrams we do for diverter switches or how they work. So that might need to be like teaming up with someone who knows how that adder works, because those directly affect the auto start. So that's something to consider. That's like a red flag right away is, okay, how do we do this? Because we've never done something
Or if it's necessary.
or if it's necessary, right? Exactly. And then LSIA, fine. I mean, it's just a breaker thing. ERMS, always going to be there. And then monitoring for pre/post signal transferring. I don't know what that means. So that's why I put it in red. That to me, that almost sounds like auxiliary contact, kind of, or it could be over a COM30 or Ethernet, but that would need to be clarified for sure.
Jack, is this something that a riser diagram would potentially help us out with?
Some of it could, but a lot of this stuff, a lot of riser diagrams don't have controls connections on them.
Okay.
So
okay.
you wouldn't be able to necessarily see the Ethernet going places, but yeah, I mean, it would help us with. I mean, in this case, it's not so helpful, but with a lot of the quotes, I do foresee it helping with some of these types of items for sure.
I can see the questions that we're asking CX evolving over time as we start to understand this stuff a little bit better. You know, chances are you'll see it again.
And-
Yeah, that's what we had said earlier too.
Yeah, and absolutely. It's like, this could be something, and I don't know what they're referring to here, but this could be something that we can already do. It's just we haven't made the nomenclature right yet, you know, between the teams. So I'm sure this was something that the customer just said and was just put in the quote.
Yeah.
Would be nice. Yep. So, and then, you know, and that's kind of why stuff like this is kind of, and I wanted to pull this as an example, is like why I'm not just giving an Excel document with a bunch of configurations, because in the end, this is a platform that we got to understand how it works and how we adapt it, you know, as we're going through. Would assume so, because I've never seen that called
So it's
out.
not our language.
Yeah, well,
Somebody else.
we put it in there, but I mean, I've never seen that call out, and typically the CX people don't just make up their own
Yeah.
stuff.
So.
Oh, okay, sorry. I know. Okay.
Oh, okay. Well, so tell us more, Jake. So, you know, well, you and I, Jack, but it was really your questions, funnel the questions through Aaron. Basically the slide you had before, and we got some answers, but Aaron is asking if we have follow-up questions. I think, so it sounds like we do.
This is not the DPass unit. This is the other unit sitting in the backlog.
Oh,
I'm doing, because
I'm sorry. I'm
they're going to be the
confused.
first ones, order executions processing.
And was that order also accepted?
What?
Yes, it was accepted.
God damn.
Yeah, that's
Okay.
This
That's
is the
what I'm
other order we have
saying.
in the back.
We get this one? All right, I see that.
This is the other order we have in the back.
And
Yeah.
there's a ton of them in the, I don't know how many are out in the wild, like.
But hold on. No, let's talk. No, it's a general concern. We haven't implemented it, but Jack and I had talked about a training cycle that involves telling you, doing it together, and watching you do it. Okay. So I don't know how it will work out, but the DPass order that's next, I talked with Jack. We're gonna consider that within the scope of the current DIT project. Okay. But the other one that's in the backlog, I think it would be good for order execution to do with oversight. That's the watching you, they doing it together or something like that, correct? So that's the part we need to coordinate. How is it that you pull on Jack's knowledge without making Jack part of the OE team? Okay, so that's for you to think about, but the idea is not, hey, here's over the fence, goodbye. That's not what it is. This is a work you have to understand what it's about. You have an order that you're expected to process, but you're not alone. How do you then pool the resource to help you process that order? Okay? Because we're trying to figure out the transfer, okay? At least I'm trying to figure it out. And this is kind of a guinea pig, okay? So as we go to other products, then we start laying out the foundation for how we transfer the orders. But I would think about at least 2, if not 3 cycles. You see us do it, we do it together, and we see you do it. I hope you remember that discussion. Okay. So your homework will be, okay, I'm responsible for that order. How am I gonna process that order knowing that I have a coach? How am I gonna use the coach?
So how are we going to time these? Is this going to be considered a custom job? Because this seems like this would take much longer to do than.
Well, I don't know. I don't have answers, but I would say, why don't you guys figure out what you need and let's reconvene as to how do we do this together, correct? You don't have to figure it out now, but the only thing that I think I would like to leave this meeting with is that's your order to process.
Yeah, I'm just thinking, like, especially if you're having one job, be one where we're doing it as a collaborative effort for training purposes or oversight purposes or both. You want multiple people doing it so that.
You decide that.
Multiple people.
Yeah, you decide that.
Yeah, I'm not saying to decide, I'm saying that's something that want to make sure is being considered.
So
That
Samantha's
it's going to be
listening.
a couple of us not doing normal workflow because we're doing this piece of normal workflow, which will take longer than most normal workflow jobs.
I have no say on that. That's for Samantha and Scott to figure out, but we don't have to figure out right now. The idea is, it's our intention as a DIT project to be fully available as a coach for you to process that order, while Jack considers the DPAS order as part of the scope for now.
Yeah, I think that's a good approach.
Awesome.
Yeah, so figure it out and tell us.
Yep.
Okay.
Last slide, and sorry if I disconnect. I perfectly timed my laptop battery to be done at 4, I guess. So,
But I talk too much.
Clear the screen up and use the TV monitor.
so I have a potential change. I just quickly list them all out as a thing. Switch, 240, include redundant power from generator battery, voltage sensing relay mounted on front panel, hinged door except for instead of gland plate. Like, those are just major items that stick out to me. And then in subscript, I have fixed deluxe pad mount because that unit has a lot of stuff going on with it, but I know that's not high on the priority list.
No, but hold on a second. Advit has a Power Mount 2.1 Deluxe project.
Correct, yep.
So why are we fixing this?
No,
Because
I
you don't
just-
think his approach will work?
No,
No.
there's stuff to consider. Like the deluxe pad mount has this problem. Same with their triple breaker pad mount. And the biggest one that comes to mind is even with the one line that Jack's built before, is it's not designed for a Kirk key, but yet we make a Kirk key door work in there. And so the floor, it drills into the side of the pad mount to be able to
They
bolt
have
that
to.
Kirk key door into it. And
Okay, so here's how, in my ideal la land, how this works. These are recommendations for further work that should be at the front of the funnel. And so there should be, we don't have it right now, should be an idea collection system. In this case, it might be for MCS, okay? So you don't just put it in here.
Uh-oh.
Battery died.
That's a
Yep.
good spot. It's good enough as any, right? That works for me.
Yep.
All right, thanks, guys.
I see ya.
Bye-bye.